Welcome to The Science of Crystal Clear, where we dive deep into the fascinating world of water treatment technology. I'm your host, Sage Dazzle, and today we're exploring a revolution that's happening right in our backyards, quite literally. We're talking about swimming pool filtration, and specifically a breakthrough technology that's transforming how we think about clean, healthy pool water. Now, before you think this might be dry technical content, let me ask you something. Have you ever wondered why some pools have that crystal clear, almost drinking water quality, while others seem perpetually cloudy or require constant chemical adjustments? Or perhaps you've noticed that strong chlorine smell at some pools that makes your eyes water and skin itch? Today we're going to uncover the science behind these differences and explore how a Scottish company called Dryden Aqua has developed what many consider the most significant advancement in pool filtration in over a century. We'll journey from the basic sand filters of the early 1900s all the way to today's revolutionary hydroxyl-activated glass media that actually prevents bacterial growth at the molecular level. Let's start our journey by understanding what pool filtration actually does and why it matters so much. Think of your pool filter as both the heart and lungs of your swimming pool system. Just like your heart pumps blood through your body and your lungs clean that blood by removing carbon dioxide and adding oxygen, your pool filter circulates water while removing contaminants. But here's where it gets interesting from a scientific perspective. Pool filtration operates on what we call mechanical separation. Essentially, we're separating water from debris through either surface filtration or depth filtration. Surface filtration works like a strainer, catching particles on the surface of the filter media. Depth filtration, on the other hand, captures particles throughout the entire depth of the filter bed. Now, to really understand why filtration technology matters, we need to think about what we're actually trying to remove from pool water. We're dealing with particles of vastly different sizes, from large debris like leaves that might be several centimeters across, all the way down to bacteria that measure just 1 to 2 microns. To put that in perspective, a human hair is about 100 microns wide, so we're talking about particles that are 50 to 100 times smaller than the width of a hair. Traditional sand filters, which have been the standard for over a century, can only reliably capture particles down to about 20 to 40 microns. That means they're missing a huge range of contaminants that can affect water quality, clarity, and safety. It's like trying to catch minnows with a fishing net designed for salmon. Some will get through. This limitation has traditionally been addressed by adding chemicals, chlorine for disinfection, clarifiers to clump small particles together, and algicides to prevent algae growth. But what if we could engineer a filter media that could capture those tiny particles mechanically? That's exactly what the newest generation of filter technology achieves. To appreciate where we are today, let's take a quick journey through the evolution of pool filtration technology. Picture this. It's 1905, and you're a wealthy homeowner with one of the few private swimming pools in existence. When your pool gets dirty, you have exactly one option: drain it completely and refill it with fresh water. There's no filtration system, no chemical treatment, just pure brute force water replacement. The first breakthrough came around 1910, when engineers developed basic sand filtration systems that used gravity to push water through layers of sand. These primitive systems were a marvel of their time, but they required constant maintenance and still allowed many contaminants to pass through. Interestingly, 1910 was also when Brown University pioneered the use of chlorine for swimming pool sanitation, marking the beginning of modern pool water treatment. The next major leap came in the 1950s with the introduction of diatomaceous earth filters, or DE filters as they're commonly known. These systems used fossilized microscopic organisms to create an extremely fine filtering medium capable of capturing particles as small as 2 to 5 microns. This was revolutionary. Suddenly, pool water could achieve a level of clarity that had never been possible before. Cartridge filters emerged around the same time, offering a more user-friendly approach. Instead of dealing with messy DE powder or backwashing sand, pool owners could simply replace cartridge elements. These typically capture particles down to about 10 to 15 microns. But here's where the story gets really interesting. For decades, the industry essentially plateaued. Sure, there were improvements in pump efficiency, better pool chemistry, and automated systems, but the fundamental filtration technology remained largely unchanged. Sand was still sand, DE was still DE, and cartridge materials saw only incremental improvements. Then, in the late 20th century, engineers began asking a different question. Instead of just trying to make better strainers, what if we could engineer the filter media itself at the molecular level to have entirely new properties? What if we could create a material that not only filtered better, but actually prevented bacterial growth and lasted decades instead of years? This question led to 35 years of research and development by marine biologists at Dryden Aqua in Scotland, culminating in what they call AFMNG, Activated Filter Media Next Generation. Now we're getting to the heart of our story, and this is where the science becomes truly fascinating. AFMNG isn't just a better filter media, it's a completely different approach to water treatment that operates on multiple levels simultaneously. Let me start by explaining what AFMNG actually is. At its core, it's made from recycled glass, specifically green and brown glass bottles that would otherwise end up in landfills. But here's where it gets interesting. This isn't just crushed glass. The material undergoes what Dryden Aqua calls a 3-step hydroxyl activation process that fundamentally transforms its properties. Think of it like this. Imagine you could take a piece of ordinary glass and not only make its surface area 300 times larger, but also give it the to actively fight bacteria and attract specific types of contaminants. That's essentially what hydroxyl activation achieves. The process begins with careful selection of glass types. Green and brown bottles are chosen specifically because they contain metal oxides, compounds of metals like iron, chromium, and copper combined with oxygen. These metal oxides are crucial because they'll eventually become the catalytic sites that give AFMNG its unique properties. The glass is then processed to achieve optimal grain size and shape. This isn't random crushing. The grain structure is engineered to provide specific hydraulic properties while maximizing surface area. But the real magic happens in the third step, the hydroxyl activation treatment itself. During this process, the glass undergoes chemical and thermal treatment that creates what scientists call a mesoporous structure. Think of it like transforming a smooth marble into a microscopic sponge with countless tiny chambers and passages. This increases the surface area from about 3,000 square meters per 1,000 kilograms for sand to an astounding 50,000 square meters per 1,000 kilograms for AFMNG. But surface area is just the beginning. The activation process also incorporates those metal oxide catalysts we mentioned into the structure in a very specific way. These catalysts can dissociate water and oxygen molecules, creating what are called free radicals, specifically hydroxyl radicals. Now, hydroxyl radicals are some of the most powerful oxidizing agents in nature. Your own immune system actually uses them to kill invading bacteria. They're incredibly reactive and have lifespans measured in nanoseconds, but in those brief moments, they can destroy bacterial cell walls, proteins, and DNA. The genius of AFMNG is that it creates these hydroxyl radicals continuously on its surface as water flows through. It's like having a molecular-level defense system that's always active, always protecting the filter media from bacterial colonization. Let's talk about what all this molecular engineering actually achieves in practical terms, because the performance differences are honestly quite remarkable. Traditional sand filters, as we mentioned, capture particles down to about 20 to 40 microns. Standard recycled glass does slightly better at around 25 microns. But AFMNG, with its activated surface and mesoporous structure, has been independently tested and certified to filter 95% of particles down to 1 micron without any additional chemicals or coagulants. To put this in perspective, bacteria typically range from 1 to 5 microns, many viruses are smaller than 1 micron, and parasites like Cryptosporidium are around 4 to 6 microns. We're talking about a filter media that can mechanically remove most biological contaminants that traditional sand filters simply cannot touch. But mechanical filtration is just one of 3 different filtration mechanisms that AFMNG employs simultaneously. The second mechanism is electrostatic attraction. The activation process creates a strong negative charge on the AFMNG surface, which attracts and holds positively charged particles and dissolved organic molecules. It's like the media has its own magnetic field for contaminants. The third mechanism is what's called hydrophobic adsorption. And this is particularly clever. The newest generation of AFMNG has a hydrophobic surface, meaning it repels water but attracts oil-like substances. Organic contaminants, bacteria, and even microplastics tend to be hydrophobic, so they're naturally drawn to and captured by the AFMNG surface. Here's where it gets really interesting from a chemistry standpoint. By removing organic matter so effectively, AFMNG dramatically reduces what we call the organic load in pool water. Organic matter consumes chlorine and serves as food for bacteria. When you remove it, you need up to 50% less chlorine to maintain proper sanitization levels. But there's another benefit that's equally important. When chlorine reacts with organic matter, it forms compounds called trihalomethanes, or THMS. These include chloroform and other compounds that are considered potential carcinogens and are responsible for that harsh chlorine smell and irritation we associate with overchlorinated pools. By removing the organic precursors, AFMNG significantly reduces THM formation. The result is water that not only looks clearer, but actually is chemically cleaner and healthier. Pool operators report dramatic improvements in air quality around indoor pools, reduced skin and eye irritation, and that characteristic harsh chemical smell essentially disappears. One of the most remarkable aspects of AFMNG technology is something that challenges our basic assumptions about how filter media should work. For over a century, we've accepted that filter media will gradually become less effective as it accumulates contaminants and develops bacterial biofilms. With sand filters, this leads to channeling, where water finds paths of least resistance through the filter bed, bypassing proper filtration. But AFMNG turns this conventional wisdom on its head through what Dryden Aqua calls bioresistance. Remember those hydroxyl radicals we discussed? They create a continuously hostile environment for bacteria on the media surface. Unlike sand, which becomes a breeding ground for bacteria within days, AFMNG actively prevents bacterial colonization. Let me explain why this matters so much. In traditional sand filters, bacteria don't just live harmlessly in the media. They form protective structures called biofilms. These biofilms can harbor dangerous pathogens like Legionella, Pseudomonas, and Cryptosporidium. Essentially, your filter becomes a reservoir of the very contaminants you're trying to remove from your pool. With AFMNG, the continuous generation of hydroxyl radicals prevents any biofilm formation. The filter media actually becomes cleaner over time rather than dirtier. This explains why AFMNG maintains its 1-micron filtration performance throughout its operational life, while sand filters typically degrade to 40 to 60 micron effectiveness as they become biofouled. The practical implications of this are enormous. Traditional sand needs replacement every 3 to 5 years as it becomes contaminated and develops channeling. AFMNG has documented performance exceeding 15 years in commercial applications without any degradation in filtration efficiency. From a maintenance standpoint, this bioresistance also means AFMNG requires about 50% less backwashing than sand. The hydrophobic surface doesn't allow particles to strongly adhere to the media, so they're more easily removed during cleaning cycles. This translates to significant water conservation, thousands of gallons saved annually for a typical residential pool. As we become increasingly conscious of our environmental footprint, it's worth examining how advanced filtration technology like AFMNG fits into the broader picture of sustainable pool operation. Let's start with the manufacturing process. AFMNG is made from recycled glass bottles, specifically green and brown bottles that might otherwise end up in landfills. This upcycling process gives waste materials a second life as a high-performance filtration medium, but the environmental benefits extend far beyond just recycling. The water conservation we mentioned is significant. In regions where water is scarce or expensive, reducing backwash requirements by 50% can save thousands of gallons annually, but the chemical reduction is equally important from an environmental perspective. By reducing chlorine consumption by up to 50%, AFMNG dramatically decreases the environmental impact associated with chlorine production, transportation, and storage. Chlorine manufacturing is energy-intensive and produces greenhouse gases, so using less chlorine has a meaningful environmental benefit. The reduction in disinfection byproducts is also environmentally significant. THMs and other chlorination byproducts don't just disappear, they can accumulate in pool water and eventually enter wastewater streams when pools are drained or when backwash water is discharged. By preventing their formation in the first place, AFMNG reduces this environmental burden. The longevity of AFMNG also matters from a sustainability standpoint. Traditional sand needs replacement every few years, generating waste and requiring new mining operations. AFMNG can last 10 to 15 years or more, dramatically reducing material consumption over the life of a pool. From an economic perspective, while AFMNG costs 2 to 3 times more than sand initially, the total cost of ownership is significantly lower. When you factor in the reduced chemical consumption, lower water usage, decreased maintenance requirements, and extended lifespan, most pool owners see a positive return on investment within 2 to 3 years. Let's bring this technology down to earth and talk about what it means for actual pool owners, particularly in the Canadian context where our research focuses. Canada presents unique challenges for pool filtration systems. Our climate means most pools are seasonal, requiring winterization and startup procedures that can stress filter media. The freeze-thaw cycles that sand filters experience can cause structural damage and channeling problems. AFMNG's activated glass structure maintains its integrity through these temperature extremes much better than traditional sand. Canadian regulations also tend to be quite strict regarding water quality and discharge. Many provinces have regulations about pool water discharge that favor technologies like AFMNG. The reduced backwashing requirements and improved water quality make compliance easier while reducing operational costs. Installation of AFMNG is remarkably straightforward. It's a direct replacement for sand in existing sand filter systems. No modifications to plumbing or equipment are required. The media is available in different grades to optimize performance: Grade 0 for the finest filtration, Grade 1 as the primary filtration layer, and Grade 2 for support and coarser filtration. For Canadian pool owners, the technology is particularly attractive because it works seamlessly with all sanitization methods: chlorine, saltwater, bromine, and UV systems. This compatibility means you're not locked into any particular water treatment approach. Real-world feedback from pool owners who've upgraded to AFMNG consistently reports dramatic improvements in water clarity, reduced chemical costs, and decreased maintenance time. Many report that their pools achieve a clarity level they never thought possible with their existing equipment. The technology is particularly beneficial for pools with high bather loads, outdoor pools that deal with organic contamination from windblown debris, and indoor pools where air quality is a concern. The reduction in chloramines that AFMNG achieves can transform the environment around indoor pools, eliminating that harsh chemical atmosphere that many people associate with pool facilities. As we near the end of our deep dive, I want to return to the fundamental question that drives innovation. What makes AFMNG truly different from incremental improvements in existing technology? The answer lies in what scientists call paradigm shift, a fundamental change in approach rather than just better execution of the same old methods. For over a century, pool filtration has been primarily passive. We pushed water through a medium and hoped to catch contaminants. Even improvements like DE filters and cartridge systems were essentially better strainers. AFMNG represents active filtration technology. The media doesn't just sit there waiting for contaminants. It actively works to attract, capture, and neutralize them through multiple mechanisms operating simultaneously. The mesoporous structure provides mechanical filtration, the negative surface charge provides electrostatic attraction, the hydrophobic surface targets organic matter, and the hydroxyl radical generation provides continuous sterilization. This multi-mechanism approach is what allows AFMNG to achieve performance levels that would be impossible with any single filtration technology. It's the difference between a basic tool and a sophisticated system engineered at the molecular level to optimize every aspect of its function. The research and development behind this technology spans 35 years and represents the work of marine biologists who understand water systems at a fundamental level. This isn't just engineering, it's applied marine biology, chemistry, and materials science working together. What's particularly elegant about the solution is that it addresses multiple problems simultaneously. Traditional approaches often involve trade-offs: better filtration but higher maintenance, chemical reduction but compromised sanitation, longer media life but reduced performance. AFMNG manages to improve performance while reducing maintenance, decrease chemical consumption while improving sanitation, and extend media life while maintaining effectiveness. As we look toward the future, AFMNG represents more than just a better filter media. It points toward a fundamental transformation in how we think about pool water treatment. The integration of smart pool systems with predictable, high-performance filtration media like AFMNG opens up possibilities for much more sophisticated automated control. When your filter media maintains consistent performance characteristics over its entire lifespan, automation systems can make more accurate predictions and adjustments. We're also seeing AFMNG technology expanding beyond swimming pools into broader water treatment applications. The same principles that make it effective for pool filtration, superior particle removal, organic matter adsorption, and bioresistance are valuable for drinking water treatment, industrial process water, and wastewater treatment. The environmental consciousness that's driving adoption of AFMNG is also pushing the industry toward more sustainable practices overall. Variable speed pumps, solar heating, and advanced water chemistry management are all part of a broader movement toward more efficient, environmentally responsible pool operation. From a regulatory standpoint, we can expect increasingly strict standards for both water quality and environmental impact. Technologies like AFMNG that can meet higher performance standards while reducing resource consumption are likely to become not just preferred, but required in many applications. The research continues as well. Dryden Aqua is working on even more specialized activation processes for specific contaminants, including enhanced removal of emerging contaminants like pharmaceutical residues and microplastics. The fundamental technology platform they've developed with hydroxyl activation provides a foundation for continued innovation. As we conclude our journey through the science of advanced pool filtration, let's step back and consider what we've learned. We've seen how pool filtration has evolved from the simple sand filters of the early 1900s to today's sophisticated, molecularly engineered systems. We've explored the fascinating science behind hydroxyl activation and how it creates filter media with properties that would have seemed impossible just a few decades ago. Most importantly, we've discovered that AFMNG represents more than just incremental improvement. It's a fundamental reimagining of what filter media can do. By operating through multiple mechanisms simultaneously and actively resisting the biological fouling that has always limited traditional media, AFMNG achieves performance levels that change what's possible in pool water treatment. For pool owners, this technology offers the promise of clearer, healthier water with reduced chemical requirements and maintenance needs. For the environment, it provides a path toward more sustainable pool operation through water conservation, chemical reduction, and waste minimization. But perhaps most significantly, AFMNG demonstrates that there's still enormous potential for innovation in industries that might seem mature and settled. When brilliant minds apply advanced scientific understanding to everyday problems, the results can be transformative. The next time you see a crystal clear pool, you might think about the sophisticated molecular processes happening invisibly in the filter system. Hydroxyl radicals working at the nanoscale to prevent bacterial growth, mesoporous structures capturing particles smaller than bacteria, and hydrophobic surfaces targeting organic contaminants, all working together to create that pristine water quality. As we move forward into an era of increasing environmental consciousness and technological sophistication, innovations like AFMNG show us what's possible when we apply rigorous science to improve both performance and sustainability. The science of crystal clear water isn't just about having a beautiful pool, it's about reimagining what's possible when we engineer solutions at the molecular level to work with natural processes rather than against them. Well, thanks for hanging in there on this really important training module. Let's get out there and bring more crystal clear to the Canadian pool market. This is Dazzle Team Brands team member Rocky, signing out.